How do engineers test the safety of long bridges? Imagine standing on a bridge that stretches across a vast body of water or deep canyon. Now, think about how engineers make sure that such a massive structure is safe for everyone. They don't just build and hope for the best. Instead, they use a variety of precise tests and checks to keep these colossal creations secure. When it comes to the longest bridges, safety testing is a detailed process that involves many steps. First, engineers begin with visual inspections. Teams look closely for cracks, rust, or any signs of wear. For hard-to-reach spots like the undersides of decks or high cables, they use special equipment like snooper trucks with extendable arms or even drones with cameras. Drones are great because they can fly over large areas and capture high-quality images without risking anyone's safety. Next, they use non-destructive testing methods. These are techniques that can find problems hidden inside the materials without damaging the structure. Ultrasonic testing sends sound waves through steel to find internal cracks. Magnetic flux leakage testing detects corrosion or metal loss by measuring changes in magnetic fields. Ground-penetrating radar uses electromagnetic waves to create images of what's beneath concrete, revealing cracks or voids. For the longest bridges, robotic systems are also used. These robots crawl along cables or other parts of the bridge, taking detailed images and data. They can cover the entire length of cables or structural elements, providing high-resolution pictures for analysis. The data collected is stored and compared over time to spot any changes. Engineers also analyze the materials used in the bridge. Portable devices help test the chemical makeup of steel and other materials right on site. This helps identify if the materials are prone to brittleness or corrosion, which could weaken the structure over time. Before opening a new long bridge to traffic, engineers perform load testing. They drive heavy trucks across the bridge to simulate years of traffic in a short period. Sensors measure how the bridge responds to this weight, checking for excessive bending, vibrations, or other signs of stress. If the bridge handles the load well, it's a good sign it can handle real-world traffic. Special parts of the bridge, like complex joints or unique features, get extra attention. Engineers do hands-on inspections and use non-destructive tests to find tiny defects that could cause big problems later. After construction, safety doesn't stop. Engineers install sensors all over the bridge to monitor movement, strain, temperature, and other factors in real time. This ongoing data helps catch small issues before they become serious. For record-breaking bridges, these checks are especially important because of their size and the attention they attract. They regularly inspect cables with robotic tools, test anchorages with ultrasonic methods, and perform load tests. They also assess how the structure behaves under extreme conditions like high winds or heavy loads. All these steps work together to make sure that even the longest and tallest bridges stay safe for decades. Engineers combine visual checks, advanced testing, robotic inspections, material analysis, load testing, and constant monitoring to keep these architectural giants secure.